Hey Chemistry, Mrs. KJ here, going over the second part of our lesson. And I hope that you saw in the previous one, I said to stop watching once I started talking about dozens. There's two different ways to do this problem, and I was going to show you the one way, but I'm going to hold off because I'm afraid it's going to be too confusing at this point. So we will get to the other way very shortly. But I figured we'd start over and try this way. So one property that scientists commonly use to identify substances is density. The density of an object is equal to the mass of the object divided by its density. A scientist determines that the mass of a sample of a material is 367.2 milligrams and that the volume is 823.8 centimeters cubed. What is the material's density in kilograms per cubic meter? All right, so the first thing we want to do is we want to pull out what we're doing. So we want our final answer to be density, okay? And so the density is going to equal something with the units kilogram per meters cubed. Then you always write down what you're starting with. All right, so we know that our mass is equal to 367.2 milligrams. And we know that our volume is equal to 823.8 centimeters cubed. And again, units are so crazy important because that's actually the whole point of this problem is converting units, because we're going to eventually put it in to density equals mass over volume, but we need to have our correct units first. Okay, so let's start with the mass. We're starting with milligrams, and we're going to what? Kilograms. So we'll use our staircase. You pretend you are a little person, and as a little person, you start on the step of the prefix that you were given. So we're giving milligram, so we're starting on milli, and we need to go all the way to kilo. So we start hopping. 1, 2, 3, 4, 5, 6 places to get to kilo, and we move to the left. All right, so now we have to move our decimal 6 places to the left. So we move it 1 place value, 2, 3, but we're not done. We keep going. 4, 5, 6. All right, and so our decimal's right there, but what do we have to put in these little bumps that I put right there? Well, in those bumps, we have to have our zeros. So my final answer for my mass is actually 0.0003672 kilograms. All right, so now that we have our mass converted from milligrams to kilograms, now we want to switch our volume from centimeters cubed to meters cubed. Now hang on, it's not as easy as going from centimeters to meters because it's cubed. So I'm just putting this part onto a new slide just to kind of give us some room to work. So we have our volume in centimeters cubed. I want it to go to meters cubed. Again, because it's cubed, I cannot simply hop on the stair step. Instead, I have to take that into account. And an easy way to look at that is this picture. Sorry for the sound effects. All right, so let's take a look at what this is showing us. This cube is 1 meter deep, 1 meter high, and 1 meter wide. So it's 1 by 1 by 1. 1 times 1 times 1 is 1, but it's meters times meters times meters gives you 1 meter cubed. Okay, now that's 1 meter. We want to go from centimeters to meters. All right, so let's start here at the centimeters, and we are going to go to meters, which is 2 hops to the left. Okay, so 1 meter, as you hopefully remember, equals 100 centimeters. Okay, Or if we go the other direction, then we can say 1 centimeter equals 0.01 meters. All right, let's look at what direction we want to go. So we're starting out with centimeters, we're going to meters. Well, let's look here. 1 meter equals 100 centimeters. So in this diagram, each box represents how many centimeters? 10. So I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 centimeters. Okay, let's go vertical. I have a meter going up, which is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 centimeters in this direction. So 100 centimeters. And I need to go deep. Okay, so I took care of our first set of blocks here, but now I got to take care of this row. So this row, and the next row, and the next row, and all the way down. Now remember, this row actually includes all of these that are behind the first picture you can see. So going this way, we also have 100 centimeters. So if we were going in one direction, if we were just doing the length, we would just need our 2 hops to go from centimeters to meters. But we need to go length times width times height. So how many total hops do you think we need to do? Well, we got to do 2 for over here, 2 for over here, 2 for over here. So 2, 4, 6. We're going to have to move our decimal place 6 times in order to convert from cubic centimeters into cubic meters. All right, so we're going to move our decimal point 6 places to the left. So we're going to move it 1, 2 to show going from centimeters to meters along the length. 1, 2 for going from centimeters to meters along the height. 1, 2 for going from centimeters to meters along the depth. And so we're going to rewrite our number to 0.0008238. So if you're feeling right now like, okay, I can go from centimeters to meters, I can go from meters to centimeters, but when you cubed this, you cubed the difficulty, and now it's a big mess. That's okay. This takes a lot of thought and practice to be able to do it with the cubing. The main reason for them showing this problem was to show how the cubed unit really does matter. So let's take our answer here and let's put it back on our previous page. So our volume equaled, my mouse isn't working, equals, there you go, 0.000823 meters. Are we done? No! Meters cubed. Don't forget the cubed. All right, so we need to put it into our equation now. So density equals mass over volume. So density equals our new mass is 0.0003672 kilograms over 0.000823 meter. Oops, I forgot the 8 at the end, didn't I? Squeeze that 8 in there. 38 meters cubed. And you are going to put that into your calculator. So 672 divided by 0.000823 gives us an answer of 0.44, come back, 57. Or if I told you to round to hundredths, which is what we're going to do in this class, what would your answer be rounded to hundredths? 0.45. And what's our unit? Kilograms per meters cubed. All right, If you are looking at the book, you're going to notice that you may or may not have noticed, but there's a typo. They showed you the other way of doing this problem, which is perfectly acceptable, except for the fact that it's not letting me zoom out and show you, except they said, there we go, to do 1,000 cubed, but it's only 100, okay? So in case you looked at that and were wondering what was going on. All right, let's look at the problems on the bottom. Number 1, a scientist needs to measure the mass, temperature, and luminosity intensity of a light bulb. What 3 SI base units will the scientist's measurements include? Hit pause. What's your answer? So mass is grams or kilograms, I would accept. Temperature is technically Kelvin. And luminosity is candelas. All right, perform the following unit conversions. 134 kilometers to centimeters. We're going to skip this one. And then 0.65 millimoles to moles. So just do the first one and the last one. Hit pause, get your answer. All right, so I got everything set up. So let's change from 134 kilometers to centimeters, and you should have this answer already. So again, you pretend you're a little person on the steps. You start with the unit you're given with, and we're going to centimeters. So 1, 2, 3, 4, 5 hops to the right, which means we take our decimal, since it's not given to us, we put it at the end of the number, and we move 1, 2, 3, 4, 5 hops to the right. And what do we fill in all those empty spaces with? Well, if nothing goes there, then you fill it in simply with a 0. So 1, 2, 3, 4, 5 zeros. If we write it a little bit more neatly over here, and we have our 5 zeros, and then you can add in your commas, and you can see our answer is 13,400,000 centimeters. All right, let's go to the next one. We are going from millimole to mole. So I'm starting at milli, and I'm going to mole, which is 1, 2, 3 hops to the left. So I take my decimal, and I move it 1, 2, 3 hops to the left. And again, what do I fill in those empty spaces with? Zeros. So my answer is 0.00065 moles. All right, if you haven't yet, go ahead and do both parts of problem 3. So hit the pause button and make sure that you do that. So we need to change centimeters into the base unit. So the base unit for length is meters. Okay. So we start at centimeters, we go to meters, 1, 2 hops to the left, you take your decimal and you move it 1, 2 hops to the left. So remember, you start with where the decimal is. You only put it at the end of the number if a decimal is not given to you. So your answer is 0.452 meters. All right, now let's convert 195.6 milligrams into the standard base unit, which is kilograms. I don't know why it's not grams. I'm not the one who invented it. So we will go ahead and we're starting on milligrams. So we'll start down here and we're going to kilos. So 1, 2, 3, 4, 5, 6 hops to the left. So 1, 2, 3, 4, 5, 6. We'll squeeze that in there. And we rewrite it as 0.0001956 kilograms. All right, now I took screenshots of this page and this page as well as our other page, and I added all that to the notes so that you have that all written down. And I will do the next part in the next video.